All right. Well, now that we're a little more awake than we originally were about 5 minutes ago. No, yeah, some people, I mean, you can really tell who's desensitized to violence in this nation, who isn't. You'll say, well, it's fun. Okay. So we want to go ahead and finish up the lesson we started on yesterday. It is not going to take us very long. I want to wrap up the continuity test, but also our discussion about limits and end behavior. If you've not turned in your inequality homework, try to get that in, as soon as possible. Remember, it's not necessary, okay? We're not taking it for a grade. It only becomes necessary if you happen to fail the test next week, because you have to have the assignment done in order to retake an assessment. Okay. In fact, as soon as we finish up with the lesson, I will pass back your quizzes. We'll talk about any questions you had on those, and that's really all we're going to do for the end of this week. In fact, if you haven't noticed yet, you did have a passing average, so you guys, a lot of people did really well on the test in here, so I'm very, very happy about that. 74.1, not the highest though. 8th period just beat you out with a 76.2. Okay. It's not to say that a lot of people didn't do really well. There were a lot of people who not only aced it, but got the bonus. There were a few folks who still scored in the 90s and the upper 80s. But there were also people who scored at the other end of that spectrum, and I'll just talk about that when we get there. Okay. So let's see. We were talking about the continuity test, and it was made up of 3 parts. Okay. Step 1, we wanted to go ahead and find out, does the function exist at my given value of x? Hello. Okay. Somebody just want to say hey. Step number 2, does the limit as we approach that value from both sides exist? And then step number 3 is where we compared the results from steps 1 and 2. We're going to go through a problem again, but on step 2, we want to try to analyze the behavior as we approach a particular value. So we want to be able to recognize certain patterns. If it turns out we're dealing with a infinite discontinuity, we refer to that as a what? A vertical asymptote, right? Well, we're going to notice that the y values as we approach an x from both sides, they're going to become extremely large or extremely small very quickly. If we notice that kind of pattern, well, we have to be dealing with an infinite discontinuity. We've been dealing with a removable discontinuity. Now here we're going to notice in step 1 that there is a problem with that x at that location, okay? But the table should show that I'm still approaching the same y value from both sides. Okay. What do you think is going to happen if it turns out to be a jump discontinuity? Will the y values approach the same or different numbers? They will approach different numbers. So if we do have a limit from the left and the right, but they are different values, that's going to lead me to believe it's got to be a jump discontinuity. Okay, well, we did one yesterday that worked out nicely. We showed that x was continuous at 2 for that quadratic. Now let's look at this guy. And you can probably tell before we even go ahead and get started what's going to happen. But this is our confirmation. This is our algebraic way of verifying what's happening, why we believe we're going to have a certain type of discontinuity. So step 1, and I always like to go ahead and write out some questions here. Does f of, now for this piecewise function, I'm interested in what value? There we go. Is this piecewise function continuous at x equals -3? Okay. Does f of -3 exist? Well, how do I determine that? Yeah, just plug it in. Okay. See if I get a y value out of it or if there's an issue that happens. Well, which one will I plug it in? The 3x minus 2 or the 2 minus x? 2 minus x. -3 belongs to this interval right here. Okay. So f of -3. So 2 minus x would be 2 minus -3, which is 5. So I did get a y value, so I'm going to say yes. Okay. Step 1 is good to go. Okay. F of -3 does exist. So step 2, now let's see what happens for the limit. Does the limit as x approach -3 of f of x exist? Okay. Now, does anybody remember what we talked about for that limit statement yesterday? He only exists if what? Okay, Will's saying exactly what's correct. We're approaching the same y value from both sides. Okay, so this statement right here, you'll notice there's no plus or minus as a power, so if that's removed, we're approaching it from both sides. So this statement right here is only true if the limit as x approaches negative 3 from the left equals the limit as x approaches negative 3 from the right. Okay. And for step number 2, that's where this table comes in. In fact, you'll notice again the value I'm interested in, negative 3. I've got that right in the middle. I've got values just below negative 3 approaching it from the left, and I've got values above negative 3 approaching it from the right. Okay, well, what I need to do is just go ahead and now plug in those numbers. In fact, all of these right here, like starting with negative 3.1, am I going to plug it into the top or the bottom function? Okay, I'm going to plug it in the bottom. Negative 3.1 is smaller than negative 3, right? Okay, so help me out with this first one. What's 2 minus negative 3.1? 5.1. Okay, these first ones right here, you probably don't need a calculator for, but feel free to use one if necessary. What if I were to plug in negative 3.01? Okay, 5 what? 0.01. And if I were to plug in negative 3.001? 5.001. Now remember, the left side of this table, okay, is the limit as we approach negative 3 from the left. So does it look like it's approaching a particular number? Looks like it's approaching what? I'd say 5. Okay. So the limit as we approach negative 3 from the left looks like I'm getting closer and closer to 5. Well, now let's go in the other direction. And this is just a habit that I got into. I start at the far end of the table and work backwards because I like to see the pattern develop. Hello. Hey. All right. So has anybody gotten negative 2.9 for me? This is the first time we're going to use 3x minus 2 because negative 2.9 is greater than negative 3. Okay. So Will says negative 10.7. Perfect. What about negative 2.99? Okay. Negative 10.97. Thank you, Sandra. Oop, that's one dot. And I got one more. Negative 2.999. Negative 10.997. Now the right side of the table, this is as I'm approaching negative 3 from the right. Well, it looks like I'm approaching what? I'm getting closer to negative 11. Okay. Now remember, this limit will only exist if I approach the same value from the left and the right. Well, 5 does not equal negative 11, so what do you think about step number 2? No, it does not exist. Now here's what's nice about the continuity test. You only have to perform step number 3 if you got a yes for both steps 1 and 2. Because in step number 3, that's where you compare the results from steps 1 and 2. So now if we're not going to go any further, okay, well, based on this pattern, we now have to be able to tell what kind of discontinuity is happening here. So I'm looking for a type of discontinuity where as I approach a value of x from both sides, I get different y values. There you go. The only one this fits, it has to be a jump discontinuity. And like I said from the beginning, knowing it's a piecewise function, we probably could have predicted that. But again, this is the algebraic way to show that. So this would be a jump discontinuity. Okay, and that's it. That is the continuity test. Okay. Anybody having trouble? Anybody have questions? Okay. Let's try another one. Okay, so now we're going to move from a piecewise function to a rational function, something we've been working with for the past couple of weeks. X plus 3 over x squared minus 9. So I want to test this function at 2 locations. So let's start with negative 3 first. Okay, so step 1, we're going to do the 3 steps for each of these. So step 1, does f of negative 3 exist? Well, step 1 is always really easy. You just take the value in question, plug it in, and see what happens. Okay. Well, let's see here. F of negative 3 equals x plus 3, negative 3 plus 3 over x squared minus 9, negative 3 squared minus 9. Well, negative 3 plus 3 will yield 0 over 9 minus 9, 0. Okay, so Does f of negative 3 exist? No. So we got a problem. Something's happening here. All right. Now, again, based on what we've spent our time discussing over the past 2 weeks with rational functions, you probably already know what's going to happen. Okay, but we're just going to go ahead and continue with the continuity test. The good news, because I got a no for number 1, I don't have to do what? I don't have to do step 3. I still want to perform step 2 because I'm looking for the behavior or the pattern. Okay, so 2, does the limit as x approaches negative 3 of f of x exist? Okay. And remember, this statement right here, as x approaches negative 3, he only exists if I get the same y value approaching x from both directions. Okay. So what do I do to figure that out? Okay. Plug in those numbers, fill in the table. So I want to take these 6 values right here. Okay. And I want to go ahead and plug them in. Now, we already know at negative 3 we have a problem. Okay. We're just trying to figure out what kind of problem that is. So somebody help me out. If I were to plug in negative 3.1, what should I get here? Negative what? Okay. Now let's go ahead and round to 3 decimal places. I think I get 0.164. Okay, there we go. We'll go ahead and round these to 3 decimal places. So all I'm doing, just like I took that negative 3 a moment ago, plugging it in for every x. So negative 3.1 plus 3 divided by negative 3.1 squared minus 9. And that's where I got the negative 0.164. Okay. Has anybody determined the negative 3.01? Negative 0.166. That's what I got. Perfect. And the negative 3.001. Negative. Okay. There we go. So 0.167. There we go. Okay. All right. Now you're going to notice something about 2 of the values on the other side. Has anybody already determined negative 2.9? Negative point. What'd you get, Sandra? Oh, I got something different. I got negative 0.169. Does anybody want me to plug this in the calculator? Anybody want me to confirm that? Plug it in the calculator? Okay. Now, because of the way we're rounding, because we're only going to take it to 3 decimal places, in fact, for both of these, it's going to look like these are identical. Negative 0.167, negative 0.167. Okay. And I can plug those in the calculator if you like. Okay, to go ahead and confirm. Okay. But here's the thing. We know that the function doesn't exist when x is negative 3, but it looks like, am I approaching the same number from both sides? So for step number 2, I can actually say, yes, this limit does exist. In fact, if you were to go ahead and convert that decimal to a fractional value, it's going to end up being negative 1/6. Okay. So what kind of discontinuity says that that value of x doesn't exist, but the limit is still there? This is a removable discontinuity. It's got to be a hole. Okay. Because remember, we've seen that before. Even though we have that hole, I'm still approaching a particular value of y. Okay. So that's absolutely right. This is a removable discontinuity. Okay. Are we ready for one on our own? Sure we are. Okay. Well, let's go ahead and do that. What we're going to go ahead and do, let me go ahead and erase this. Okay. I want you to go ahead and perform the same test for x equals 3. I got a table set up, everything you need. Okay, now while you guys are doing that, I'm going to pass back your papers. Okay. And I'll tell you what, Connor After we finish up with this problem, did you want to go ahead and take your test or quiz? Okay. Or we can just go ahead and do it now if you want. You can feel confident with it. Okay. I've got that table set up out there for you. Okay, let me go ahead and pass back, and I do have a few papers. Fernandez first. There we go. Kate. Eli. Okay. Jordan V. Will. Natalia. Z. Precise. D. Lane's not here. Noe. Andrew. Adrian. Okay, no Michael. Fernanda. Tori. Then I got a Philip. Kasha. Josh. Larissa. Cylindra. Okay. Sandra. Then I've got Emma. Jake. Galen. Laura. Adrian. Sandra. Josh. Caleb. Eli's here. Let's retake. Topsa. And Lane. Okay. And that's it. All right. Okay, so let me see if I can get somebody up here to help me out with this last problem. I'm not using the random number generator on the calculator because someone had told me that that wasn't completely random. I need something better. So I just went online and found a different one. What's the largest? Clarissa, are you in seat number 27? 30. Okay, 27's over there. Okay. So 1 to 30. Does anybody want to volunteer before I push generate? Okay, so many hands. How will I decide? Oh, I'll push generate. I got 22. So 18, 19, 20, 21, 22. That is Jake. All right. Jake says don't bother with that random number generator. I'll do it. I'm sorry, what? I can't hear you. What? Huh? Well, you're already up here, so why not? All right. Okay, so let's start with step 1. What do we do in step 1? Okay. So we see what's happening when x equals 3. Okay. So what would you say? Does f of 3 exist? No. Okay. So there is some kind of issue happening at f of 3. Again, good news because I got a no here. I don't have to do step 3. But I do want to do step 2, which involves the table. So does the limit as x approach 3 exist? Okay. All right. Well, I'm okay with you just plugging them in. If someone has a question, I can take care of it. So if you plug in negative 2.9, you get negative 10, negative 100, negative 1,000. 1,110. Hey. All right. And Jake is already back at his seat before I'm up at the board. Okay.
All right, seniors, it's time for our panoramic pictures. Before you leave,
Oh, forgot about that. Okay.
Please leave your backpacks in your classroom, as we don't need a ton of backpacks outside. They won't be in the picture anyway. When you come down, you need to come between the main school building and the east practice gym. There's going to be some letters in chalk on the ground. A 2 and a 0 stand for the class of 2020. So you need to find a space either inside the 2 or inside the 0. So again, seniors, go ahead and come on down. right outside the main office and between the west gym, and find yourself a spot between the 2 and the 0 that are on the ground. Leave your backpacks. Thank you.
All right. That's a great shirt for picture day, too. It's not being sarcastic. That's a great shirt. Everybody see what it said? Dunder Mifflin, which is a reference to The Office. Okay, great show. Unfortunately, should not have existed after Steve Carell left, but it just wasn't the same. Okay. All right, so Jake helped me out with this table here. So it looks like the limit as we approach 3 from the left, what's y approaching? Or is it even approaching a specific number? There you go. It looks to me like these y values are getting very small very quickly. So the limit as x approaches -3 from the left looks to me like it's approaching negative infinity. Well, what's happening on the right? The limit. There's Caleb. The limit as x approaches -3 from the right. Well, it looks to me like the closer I get to 3 from the right, well, I'm going to put a negative in there, sorry. I was thinking about the other one. +3 from the right, looks like, again, the y values are getting larger and larger without bound, so that goes to positive infinity. Okay. So think about the 3 types of discontinuities that we have. As I approach an x from both sides, which one describes going to positive and negative infinity? It's got to be an infinite discontinuity or a vertical asymptote. So this one is a infinite discontinuity. And again, with all the time we've spent talking about rational functions, you probably already knew the outcome before we even looked at it. If I'll go ahead and factor this, you see I have the x plus 3 over, how would I factor x squared minus 9? X plus 3, x minus 3. And you'll notice immediately, because the x plus 3's cancel, I have a what? Removable discontinuity at -3. But x minus 3 didn't cancel, so he has to be a what? He's got to be a vertical asymptote. Okay. So see, that's the point. We were still able to come to the same conclusions without looking at the function directly. We were using the continuity test. Okay, questions. Okay. All right, well, let me take care of Caleb very quickly. Okay, Caleb, here's your focus activity. Okay. Oh, and Connor, I have a focus activity for you as well, sir. Okay. We got the focus activity yesterday as well as these notes, so it should be over on the board. Okay. And Caleb, I'm going to go ahead and have you take your quiz for me, sir. Yeah. Okay. So any questions over continuity?
Can I come in during school? Before school next week? The other day, whenever I took the test, and I came back, I was very lost.
Okay. Yeah, but you have to make sure to come in.
Yes, sir.
Okay.
I'll come in.
Tuesday morning. Tuesday morning. Okay. Okay, so any questions about continuity? Okay. Well, let's go ahead and turn our attention to the quiz. Okay. Let me go ahead and erase this and get it all set for third period. Or should we, 5th and 8th? Okay, so we don't need that anymore. In fact, Caleb, we are going to go ahead and talk about the quiz, so if I can ask you to step outside, please. Okay. And actually, at this point, I'm going to stop